All right, well, here's the source side of the apparatus, okay? The speaker you see here. So signal generation starts at the function generator. The function generator here is a piece of electronics that can generate any waveform you want, but usually square wave or sine wave or triangle wave. And you can pick the amplitude from 0 to 10 volts peak to peak, something like that. And you can pick the frequency, anything from 0 to about, I think for this one, 5 megahertz. We're going to use this to generate either square waves at 1 hertz or sine waves at frequencies on the order of hundreds of hertz. Very good. So this produces an output which is going to be used to drive the speaker. It doesn't drive the speaker directly though, because function generators don't normally source a lot of power. So we need to amplify the signal first. For that, we have an audio amplifier. It looks like an amplifier you might see in your car. I think that's what these are usually used for. And it just has an on and off switch and a volume button and treble and bass adjusters, which are different kinds of volume buttons, I guess. And we'll use the volume control here to vary the amplitude of the signal at the speaker because it's so convenient. Okay? The output of the amplifier goes to the speaker, as shown here. It's just a set of connectors, and then that voltage will drive the speaker. And as I mentioned before, it's actually the current traveling through the circuit that's used to energize an electromagnet inside of the speaker cone. And the electromagnet is placed next to a permanent magnet, and so as you energize the electromagnet, it moves back and forth, and that drives the speaker cone, producing the sound. Very good. That's the speaker side. Okay, here's the microphone side of the apparatus. The microphone here, as I said, is mounted on this movable stage. Okay, the microphone, attached to the microphone is a pair of wires, and that couples to a feed through, and then it couples to a BNC cable to the detection electronics. As I mentioned before, the microphone signal is a low voltage, high impedance signal, and we need to boost it before we can measure it with a computer. So for that purpose, we have an audio amplifier. I'll turn it on here. And this is just a times 100 amplifier that boosts the signal to a more measurable range. And the signal is then coupled into the analog to digital converter for the computer. By the way, this box is not the analog to digital converter itself. That's a card that's mounted now on the computer chassis. This is just a convenient breakout box so we can easily connect things to it. So the microphone signal is connected to channel 0, input channel 0 of the analog to digital converter. By the way, we're also coupling the trigger signal from the function generator into channel 1 of the analog to digital converter, so we can measure that too. And in fact, if you look closely, you'll notice that that trigger signal is teed off. We're also using it as a trigger for our acquisition. And the meaning of that will become clear when we take a look at the signal next.